In this video, we'll be working through problems involving kinematics. Kinematics is the analysis of the motion of a particle linking three vector quantities: displacement, velocity, and acceleration. Motion is in a straight line. Think of the particle as moving along a number line. There is a connection between displacement, velocity, and acceleration. If you differentiate displacement, you get velocity. If you differentiate velocity, you get acceleration. And going the other way, if you integrate acceleration, you get velocity. And if you integrate velocity, you get displacement. Let's go through a worked example. The displacement s meters of a particle at t seconds is modelled by the equation s of t equals 2t cubed minus 27t squared plus 84t. Part 1. Find vt and at. Part 2. Find the times at which the particle is at rest. The velocity vt is equal to s dash t. In other words, we need to differentiate s of t, which equals 6t squared minus 54t plus 84. Acceleration is equal to the differential of velocity, which equals 12t minus 54. Part 2. If a particle is at rest, its velocity is equal to 0. That means we need to put the velocity function equal to 0. Therefore, we get 6t squared minus 54t plus 84 equals 0. Now we factorize to find the times when the velocity is equal to 0. Therefore, if we factorize 6 out of the equation, we get 6 brackets t squared minus 9t plus 14 equals 0. Therefore, we get 6 brackets t minus 7 brackets t minus 2 equals 0. Therefore, t equals 7 or t equals 2. That means the particle is at rest twice at 2 seconds and 7 seconds. Now let's discuss integration and kinematics. If v is the velocity function for a particle moving along a straight line, then if we integrate the velocity function, there are two possible scenarios. We can either get the displacement, or we can get the total distance travelled. If we integrate between t1 and t2 of the velocity function, we will get the displacement. If we integrate between t1 and t2 of the absolute value of the velocity function, we will get the distance travelled. This is because if you look at the two graphs below, we have got in the first diagram 3 distinct areas. And remember, the distance travelled is the area under the velocity function. A1 and A3 are positive and A2 is negative. If we add them up, we will get the displacement. A2 is negative because the velocity is negative. In other words, the particle is moving in the opposite direction. Whereas in the second diagram, we've got exactly the same 3 areas, but this time They are always positive. We are only interested in the distance travelled. We're not interested in which direction the particle is moving. That gives us the total distance travelled. Let's go through a worked example. A particle moving in a straight horizontal line has velocity v in meters per second. At time t seconds, and is modelled by the equation, velocity with respect to t is equal to 8t cubed minus 12t squared minus 2t. Part 1. Given that the initial position of the particle is at the origin, find an expression for its displacement from the origin at time t seconds. The displacement function, s with respect to t, is given by the integral of v with respect to t, which is equal to 8t to the power of 4 over 4 minus 12t cubed over 3 minus 2t squared over 2, which simplifies to 2t to the power of 4 minus 4t cubed minus t squared plus c. Don't forget to add the plus c. We're told in the question that it is at the origin when t equals 0. Therefore, if we substitute s equals 0 and t equals 0, we can find c. Therefore, we get c is equal to 0. Therefore, the displacement function is equal to 2t to the power of 4 minus 4t cubed minus t squared. Part 2. Find the displacement of the particle from the origin in the first 5 seconds of its motion. Therefore, we need to find the integral of vt between 0 and 5, which is equal to 2t to the power of 4 minus 4t cubed minus t squared between 0 and 5, which can be solved using a GDC, which gives us 725 meters. Part 3. Find the distance travelled by the particle in the first 5 seconds. For this question, we need to find the integral between 0 and 5 of the absolute value of v with respect to t, which can be done on a GDC, giving 737 meters to 3 significant figures. Let's do another question. A particle moves along a straight line such that its displacement s in meters from an origin O is given by the equation s with respect to t is equal to t squared minus 4t plus 3, for t is between 0 and 5, where t is in seconds. Part A. Find the velocity of the particle at time t. The velocity of the particle is given by the differential of the displacement equation. Therefore, the velocity is the differential of the displacement, which is equal to 2t minus 4. Part B. Find when the particle is moving to the right and when it is moving to the left. In order to do this, we first need to find when the particle is at rest. So we need to find when the velocity is equal to 0. Therefore, 2t equals 4, therefore t equals 2, so the particle is at rest after 2 seconds. In order to test what direction the particle is moving, we need to test either side of t equals 2 to see whether the velocity is positive or negative. When t is 1, the velocity at 1 is equal to minus 2, therefore it is moving left. When t is 3, the velocity at 3 is equal to 2, therefore moving right. Therefore we can say between t is 0 and t is 2, the particle is moving left, and between t is 2 and t is 5, the particle is moving right. Part C. Draw a motion diagram for the particle. In order to do this, we need to find the distance travelled when t is 0, t is 2, and t is 5. We can work out that when t is 0, s is 3. That means it is 3 meters to the right of the origin. When t is 2, s is minus 1. That means it is minus 1 meter to the left of the origin. And when s is 5, the distance is 8, which means it is 8 meters to the right of the origin. We could draw this on a diagram as shown. Part D. Write a definite integral for the particle's displacement on the interval between t is 0 and 5, and for the distance travelled on the interval between 0 and 5. Then work out the displacement and the distance travelled using a GDC. The displacement is given by the integral between 0 and 5 of 2t minus 4 dt, which when you put it into your GDC gives 5 meters, and the total distance travelled is the integral between 0 and 5 of the absolute value of 2t minus 4 dt, which when you work it out on a calculator gives you 13 meters.